It's almost midnight. We're doing good. Might have to do 2 parts though. Okay, can this differential equation be solved using separation of variables? The short answer is yes. And to solve by separation of variables, you need to have a function of x multiplying a function of y. And that's totally what we see here. In other words, anything that involves an x can totally be isolated into a set of parentheses or something that's only multiplying a function that, e is a number, so a function that only has a variable with y. So this one's definitely yes. You can divide the e to the negative y, you can multiply the dx, and now you only have y's on one side and x's on another side. How many more do we have to go here? 3 more. All right. Okay, this time, I think what I'll do is speed the video up here so you'll hear me talk fast. It'll be fun. If you're wondering why I'm talking fast, this is why. All right, again, we're doing separation of variables here. Hopefully you see I just multiplied e to the y and multiplied dx. Now I'm ready to integrate. When I integrate e to the y dy, I'm just actually going to get e to the y. And when I integrate sine of x, I'm actually going to get negative cosine of x. And usually your x variable side gets the plus c. We definitely want to solve for y itself, which means we have to take the natural log of both sides. And that means we're just going to end up with, well, if I take ln of e to the y, ln and e cancel out. When I take ln of the other side, I have to put everything on the other side inside of ln. And so that looks like this right here. Notice I don't need absolute values. You only need absolute values if you're integrating to get ln, not if you're doing algebra and ln comes out. So integration of ln is what leads you to absolute value ln. And crap, well now I can't press enter. What have I done? Or we'll just see how fast we can go. So in this case, this is a special example. This is actually a, how do I say it? It's a exponential model. And you know you're in this case when it's a dy over dt equals ky scenario. There's a special formula that hopefully you've memorized, but I'll go through the whole thing for you. Again, it's still separation of variables. You get dy over y equals k, or equals, I guess in this case specifically, negative 7 dt. Now we integrate both sides, we end up getting ln of absolute value y equals negative 7t plus c. Now we're going to make each of these sides an exponent of e, so e to the ln of y is just y, but e to all this is, well, e to all of that. Technically this is e to the negative 7t times e to the c. When you have exponents adding, that means it was the same base multiplied. So in other words, if you ever had x squared times x cubed, this would add to be x squared plus cubed. So in other words, x to the 5th. Same thing's going on here. So in other words, we have e to the c, but e is a number, c is a number, so really e to the negative c is just multiplying by some other number. So we have e to the c, e to the negative 7t. And now the question is, let's use our initial condition, or what is c based on our initial condition? And we should get 3 when t is 0. E to the 0, or since it's negative 7, e to the 0 is 1, so c is 3, and that means our answer is right here. All right, last question. All right, the worst one. An exponential model in a word problem. Now this would be a popular FRQ question, so definitely take note of what's going on here. Let's go for it. So the rate of bacteria over time is proportional to the amount of bacteria present, kind of like the coronavirus. However much virus is present is probably relational to how much it grows. How timely. Okay, anyways, I'm going to skip the exponential model. Hopefully you see that you're going to end up with the number of bacteria is equal to c e to the k t. You're going to get that form again. Now initially, when it says 800 bacteria initially, what that means is that when t is 0, the number of bacteria is 800, which, long story short, similar to the last example, means c is 800. So now we know that the number of bacteria for any time is given by 800 e to the k t. All right, now what I also know is and they triple every 10 hours. So now what I have to do is I have to say essentially this. I know that in 1 hour, the initial 800 will triple to 24,000. So in other words, 24,000 is equal to 800 e to the k when t is 3. So now I have a way to solve for what k is. So divide the 800, you'll get 3 equals e to the k 3. Now I have to take the natural logarithm of both sides. When I take ln of 3, I just get ln of 3. When I take ln of e to all this stuff, ln and e cancel out, so I just get k times 3. And that means that k is ln of 3 divided by 3. So let me update my equation now. I now know what c is, I now know what k is, so I get bacteria in a given time is equal to 800 times e to the ln 3 divided by 3 t. So that is my precise equation. And now they want to know the bacteria. Did I make a mistake here? Yes, I did. Sorry. They said triple every 10 hours, so this should be 10, 10, 10, and whoops, that should still be 3. Divided by 10, and divided by 10. My bad. Every 10 hours. Now they want to know the number of bacteria at 4. They want me to round to the nearest integer. So this is definitely a calculator question. So you might see some modifications of this. Technically, all you have to do in the AP exam is write b of 4 is 800 e to the ln 3 over 10 times 4. That is technically correct. You don't have to actually calculate the correct answer, but here we go. Whoops. 800 e to the ln 3 divided by 10 times 4. And then it went around to the nearest integer, so that would be 1,241. All right, so good luck as you go through the differential equations unit. It can be kind of tricky, but I would definitely anticipate a separation of variables differential equation question, because if you're doing separation of variables, you're practicing integration techniques. And one thing we'll also see in the near future is typically a differential equation FRQ is going to involve an equation of a tangent line. So make sure that when we go over that, you kind of see how dy dx is really just the slope. And so you can definitely form an equation of a tangent line if you have dy dx in a particular point on a graph, because you'll have a point and a slope, so you can use the point slope form. Anyways, best of luck. Sorry for that mistake about the dividing by 10, but hopefully you noticed it before I did and realized I would hopefully get to it. So happy studying, and I miss you all, and you're the best, and I know you'll study well and do great. So